The next important topic in this chapter is about the formation of the solar system. I already put a video which is called titled the How the Solar System was Made uh, through the lesson plan. So please watch it. Okay. The solar system is about 4.6 billion years old. The solar system actually formed from a fragment of a vast cloud of interstellar gas and dust, which we call nebula. At that time, actually, the nebula only had hydrogen and helium, which were the most um, simplest atoms available. Okay, so let's go back word a little bit more. The universe actually formed between 13 and 14 billion years ago with Big Bang. A few hundred million years later, few stars actually were formed, composed of only hydrogen, helium, and lithium. Okay, and as fusion started, fusion fusion, which is a one type of thermonuclear reaction, which describes the process that the lighter elements are transformed into heavier ones, creating energy. So, which means that the lighter elements, which such as hydrogen, helium, are formed into heavier ones like lithium and the later elements in the periodic table. And in the meantime, it's going to create energy. Okay, so that's called nuclear fusion process. Because of that process, the stars actually they are going to start to emit light. At the same time, they are ejecting heavy elements and light elements into space. So then, forming solar nebula. Okay, the solar nebula they are going to collide and compress and rotate, so furthermore creating new stars and planetary system. So we are going to here focus on solar nebula. Okay, solar nebula, which is a cloud fragment from which the solar system formed. Okay, the solar nebula, because of the gravity, as you can see from this picture here. Okay, cloud of gas and dust contracts due to gravity. Okay, so they are moving towards the center. And because of the conservation of angular momentum, it means that the whole cloud, the whole nebula, has to rotate. Okay, so as it's rotating, okay, then in the meantime, actually, because of gravity, again, the materials will be attracted to the center, but then the center becomes very crowded. When it's crowded, the temperature will go up. Okay, so the temperature keeps increasing, which is hot enough to ignite thermonuclear reactions, which is the fusion process here. And then again, we said that light elements such as hydrogen and helium will be transformed into heavier elements, and then at the same time, it's going to emit energy as form of electromagnetic radiation, such as our sun in the solar system. The fusion continues today and provides the Earth with energy necessary for life. If we go back to this slide here, so the hot region is going to be at the center, the boundary becomes cooler, so as it continues to rotate, and then eventually we're going to have rocky objects in the center, and then we are going to have some icy bodies at the boundaries. Okay, so as the center of the this nebula will become eventually becoming a star, and then the outside will become actually eventually we have four inner planets, which are Mercury, Venus, Earth, and Mars, and then four outer planets, which are Jupiter, Saturn, Uranus, and Neptune. I also posted some of the notes. Actually, usually I put on Blackboard when I talk about this chapter under course documents. So please go in and take a look at them as well. Okay. And this image shows some possible planetary systems in the process of formation here. Okay. And there are many other planets which have been discovered in other solar systems, which we call actual solar system. Okay, so we have different ways that actually we can use to discover these extra solar system, because eventually if someday something happened to the earth, as we will learn about it in the chapter of stars, then that's the reason why astronomers are actively searching Earth-like planet in actual solar system in the hope that we can find something similar to Earth, and then if we need it, then we can move the human beings to those planets.